Moving on in our discussion about linear models, today you're going to be given some real life examples about when we can use the concept of y equals mx plus b in everyday life, and we're going to learn how to kind of predict the future. Now you can predict the future, but you can also find out things about in between values. Like if you know something about what happened in 1930, maybe like the price of milk, and you know the price that was 1960, the price of milk. You can make an equation, and based on that equation, figure out an unknown. Maybe something like, what was the price of milk in 1950? And we're going to talk about how to use that and how to apply the concept of y equals mx plus b to situations like that. Our objective today is to write a linear equation that represents real world data, and we're going to make some predictions from those equations. Before we move into that, I'm going to teach you about a scatter plot. A scatter plot is a graph that represents two sets of data by plotting the data as ordered pairs. Now, there is a correlation between points, and the correlation is the strength of a relationship. In other words, how accurately are the dots? How close together are they? So let's look at the 1, 2, 3, 4, 5 examples here. You can see that this one is going downhill. It tends to go downhill. And you see how all the dots are kind of real close together? That is a strong, because the dots are together, negative, because it's going downhill, correlation. And you can see that this one does tend to go down, but since the dots they're not quite as close together as these ones, we call that a weak negative correlation. One that we really can't decide if the line should go up or down, we call that no correlation. When the dots have a tendency to go up, but they're not they're not really all the way together, we call that a weak positive. And then when the dots are super close to each other, we call that a strong positive. The line of best fit is what we call the trend line that gives the most accurate model. Remember what a model is? Model of related data. Now a model, you should remember, I taught you once, a model is just an equation, everybody. A model is an equation. Correlation coefficient. The correlation coefficient indicates the strength of your correlation. The closer your value of this correlation coefficient, the closer it is to 1, and the closer it is to -1, the stronger the relationship is one to another. Okay, like the more one can predict the other. Kind of like maybe as a child grows, their age can predict their height. That's probably a pretty strong correlation. But if you said, oh, what's your age and your ring size? That's really not going to have a very strong correlation because that's kind of all scattered abroad. We might do this when we come back into school. Let's go ahead and flip over. Problem 1, using a scatter plot. The table lists average monthly temperatures and electricity costs for a Texas home in 2008. The table displays the values rounded to the nearest whole number. Make a scatter plot. How could you describe this type of correlation? So they start in January, and you can see in January you have the temperature and you have the electricity bills. Now what some people get confused about is they think that we're actually plotting the months. We're not going to plot the months. Those are just helping label, okay? What we are concerned about is, write this down please, can the temperature predict the electricity cost? Can the temperature predict the cost of the bill? Well, you guys can probably imagine that maybe it was. And it kind of depends how you run your home. Like I have gas heat in my home, so mine probably wouldn't apply to this. But like my parents, they have electric heat. So the colder it is, the more my parents use their electricity. The warmer it is, they also have to use it because of their air conditioning. So we're going to plot these and see for this particular situation, and it's just for this particular situation, Can the temperature predict the electricity bills? So let's plot 61, 150. Here's 60. Okay, this would be 160 here. So we got to go to 150. Okay, that's pretty good. Maybe move the dot over just a little bit. And this is going to be, they're not going to be perfect, but it's going to be as close as we can get. 58, 139. 67, 172. 75, 205. 79, 170. 83, 234. 84, 255. 85, 245. 81, 210. 76, 183. 65, 132. 58, 110. Now let's take a look at this person's electricity bills. We can see, and let's read the question. It says, how would you describe this particular correlation? This correlation goes uphill. Can you see how the dots are pretty close together? So I'm going to write that they're close together. And I'm also going to write that it's positive. So I'm going to call this a strong positive correlation. So what does that mean to us? This person uses more electricity the warmer it gets. And maybe this person is maybe in my situation. I use more electricity when it gets warmer because I don't use electricity that much whenever it's cold outside because my heat is in gas. I have gas heat in my house. So this person, maybe they use their air condition because as it gets warmer, their electricity bill is going up. Now the got it is done for you. We don't have to practice that anymore. It says the table shows the number of hours students spent online the day before a test and the scores on that test. Make a scatter plot. How would you describe the correlation? So the number of hours and the test score. Something that's important for you to do is to be able to pick out if this is going to be X or Y. Which one? Well, which one comes first? Which one would be the predictor? Hopefully you would say, well, how many hours they studied would probably predict how they did on the test. So we're going to put X here for the number of hours they studied and Y for the test scores. All right? And if you can remember back from 2-1, that's called independent. This one's the dependent. Okay? Even more, this one's the domain. This one's the range. Now let's look at some of our information and see what applies the best. Well, all the dots are the same in both of them. We can see that it will be strong. Now you just have to figure out, is it a negative correlation or a positive correlation? It's going downhill, so it's a negative correlation. So we can say the more time online, the less score, or the lower the score. All right. Moving on.